Great, and we are live. I will very soon share the link to the event with you. So welcome everyone to today's first virtual Pinup of MaCAD. This is the Master in Advanced Computation for Architecture and Design, where we are focused on teaching the latest digital software and computational strategies that are very relevant in the AEC field today. Because we are an online master, we have an amazing team of faculty, guests, and of course students that are joining from all over the world. And today's presentation is part of the module that is called BIM and Smart Construction, where we are focusing on the most relevant paradigms in the industry today, which are integrative modeling, collaborative workflows, cloud-based data management. This presentation will be led by Al-Bashir, who is the leader of the Digital Tools for Integrative Modeling course. Al-Bashir Talay is an Iranian computational designer, BIM coordinator, and digital fabricator. He is holding 2 IAC masters in advanced architecture and in robotics for advanced constructions. Together with Sefer, he will be leading the conversation today. And of course, they were teaching the course for digital tools for integrative modeling. We are also joined by David Andres Leon, who needs no introduction. He is our MaCAD director. He's also a senior faculty of IAC, and he's collaborated on research that was part of CITA. He's also been involved in projects such as Flora Robotica, and he's our studio faculty as well. We are also joined by Nicole Kirova, who is a Bulgarian architect and also an IAC alumni. She's now a teaching assistant and researcher in IAC. And she's developing her PhD as part of the IAC Swin offshore program. So with this, I will give the word to Ardashir, who will introduce the course and the work that you will see.
And thank you very much, Romana, and thank you for your introduction. As mentioned, this is the first spin-off about the seminar of integrative tools, digital tools for integrative modeling. And well, to have a brief about what we have been doing during this seminar, during this semester, we have started by basically introducing this, well, unfortunately, I have to say, other paradigm in AEC industry, namely the BIM paradigm, or the BIM basically systems. And well, I say unfortunately because it's not, we believe it's not supposed to be this way. So it shouldn't really be a very different approach. This is just another solution for some of the problems in the industry. And this is actually the problem we tackled during the semester. So after a brief introduction to the system, we have started exploring with the students all the new tools and all these amazing workflows that you will see in a minute in the presentations, to basically trying to close the gap between the BIM and the computational design in our case. So this was kind of a very interesting seminar even for myself, because all the tools we used here, especially like we focused on Rhino.Inside as a new plugin for Grasshopper, which is, well, I personally believe it as a game changer, but I know I'm not talking for myself only when I say this. And so we have started exploring all these new tools, and we tried to come up with all these amazing workflows. And well, it was more of an exploration or experimental exploration of how feasible it is to bring these two fields together. What you're going to see during this presentation is basically the students who have been working or creating these workflows for their studio projects. So they won't be talking too much about the design itself, because that will be another presentation for the studio. However, we are focusing more on the workflows and how these workflows have helped them and have facilitated the whole system. So I think with this, and since we are also a bit short in time. Maybe we start with the presentations.
Great.
Sounds good.
Do you want to share the student videos? So we didn't say this, but the format for this presentation is that the students recorded videos of their work, and we will share the video and start a discussion from this video.
Okay, so should I share the videos or do you play them?
Yes, if you want to, it would be best if you have control over this so that you can really lead the discussion.
Okay. So let me share the screen.
Hello, this is Group 1 project.
Just a question: are these groups are not the same groups as they are the same groups as the studio, no?
Yeah, they are the same groups
Yes,
as
they
the
are.
studio because they're working on the same studio project. So they
Excellent.
thought they have to work in the same groups.
Okay.
So do you see the screen now?
Yes.
Yep.
Okay, so this is the project from Group 1. Yara, Andre, and Alexander, and Philip, say no more.
Hello, this is Group 1 project, which is a group of 3, myself, Yara, and Andre, and Alexander. And it's basically a hospital and research center collaboration methodology that we were initiated based on. Serves as a facility that operates based on the between all members of the settlement, or in a sense, all projects, which consist of different programs. And then with the initial studies, the whole projects, we decided to allocate ourselves between the Space Factory Business Center and the hospital will consist of the most urgent functions. Such on the other side, the lab will just have the research offices, biotech lab, where the further research can take place, and as well as the prototype workshops. This is the overview of the whole site or the moon colony site plan. And here is a more detailed site map that shows our location, which as mentioned is between the space residence right now and the space farm as an alteration for the other programs decided to have a different location.
Then we went on to develop a program for both of our functions. In this particular project, we wanted to focus our design on the space syntax. So we created a connection matrix and specified all the areas, connections, and floors for each function, which then we fed into an algorithm that we prepared, which takes all the information that we gave and creates a space syntax relation, which are then translated into actual rooms and functions. The next part that we were developing was the exterior skin, which was developed using kangaroo and inflation methodology. The next part was to take all this part of the project and transfer it to Revit.
It's just a text diagram which shows how we really utilize these 3 platforms or 2 platforms basically. So as I mentioned, Space Syntax is the core design motive in this project, where we Alex studied the connection logic, circulation design, and the grammatic data, which then internalized into Rhino.Inside, as in floors and adding levels, walls. And then on the other side, also from Grasshopper, we have the data from the structural envelope, which has the structural beams and the regular glass panels, which then internalize as well. And then as a conclusion or as outputs, Revit was the platform where it's done for its documentation. And this diagram really shows or picked the most used components in Rhino.Inside. As you can see, adding by wall, and then used here as a curve, since we're having the curves, floor plans as curves from Space Syntax. And that applies to, for the envelope elements, we had it as in a mesh using direct shape, where we added more details using the adding material, naming, and categorizing these components differently. And so here is the floor plan for the first or the 0 level. And then in the next slides, each floor plan will have a room legend, which has been done in Revit. So I'm gonna go quickly through these floor plans, and where the graphics also has been decided in Revit. All the coloring system has been decided using Revit as well. So here is the floor plans, and now the sections. Where we see the different cutting system for different structural components. And finally, just wanted to mention this slide where we want to have a more detailed sections or zoomed in detailed sections for further to study the space between the walls and then the building envelope. And finally, the construction material, and using Revit, it helped us to generate exploded diagrams, which helped to explain the construction and material approach that we have decided. So Andrea was the collaborative responsibility to study the materiality. And here a quick kind of diagrams for the door schedule that we're trying to generate, as more to come while the design study develops. And finally, now we're gonna, me and Alex just mentioned the pros and cons. I will just quickly start with the pros. So Revit really helped us to document the project, and there's no need really to say further on this point, as it's very well known for its documentation. But then with the use of Rhino.Inside, it really helped to integrate more complex geometries and meshes within this kind of documentation process. The second point, with the help of Speckle, it was possible for collaborators to update the project.
Having a lot of benefits, or it also has a few cons, which we encountered during the program. The first one was the limitation in the use of the wall creation node in Grasshopper inside Revit, which wouldn't allow us to use curves as inputs to walls. The second issue was the fact that each time we opened Revit, and Grasshopper inside Revit, the geometry would get created by Grasshopper would get duplicated. The third thing is the mesh representation. When using the direct shape to create a mesh from Rhino to Revit, it creates the display is not aesthetically perfect, and like those are the cons that we encountered.
So just to sum up, maybe if we had the possibility to go back and redo the project, we would probably utilize Speckle even more and to incorporate it even further to the project between the collaborators. And then for me personally, the duplication issue has been a great one. It's kind of a time consuming. We as a team, we thought like if we had the Revit basics and concrete background and a better foundation to use Revit, it would have been really a push for the project to produce even better documentation. And this is the kind of the next mission for us as individuals, is really to go back and learn more about Revit basics. And finally, just to conclude with a quick render that has been basically produced by Revit, but then edited further in different programs, platforms such as Photoshop. And that's it really from this work project. And thank you for your time.
Thank you. And I think also thank you from Andre, whose internet connection is unstable.
Okay. I think we missed the point to mention in the very beginning that the projects, because we asked the students not to basically go too deep about the design of the projects, but we totally forgot to mention that the projects are designed on the moon. And this is basically a very special design case. So maybe David, maybe you want to explain a bit about the, like, in 1 minute explanation of what they've been designing, basically?
Yeah, maybe just to add to that. So the projects that you'll see on this on this pinup are based on the studio projects of the same module of MaCAD, which is the Bim Smart Construction Studio. And we've decided this term to focus to place projects on the moon in order to promote that the projects have a certain level of complexity, but also nuanced components that would, in a way, also propose a challenge for them to document them, and not as opposed to standard components, which are the ones that you would find mostly here on Earth. So that was mainly the excuse that we took to make moon-based projects, and that's why all of the projects are located in the moon.
Okay, very interesting project actually been developed during the studio project, and they were mostly very challenging, even for a normal modeling system. Let go of basically integrating the BIM systems with all this complication that been developed in the studio projects.
Absolutely.
So this was really a very interesting exploration, to be honest. So does anyone want to start on commenting, or should I start myself?
Maybe I have just a couple of questions rather than comments, because I think it's super clear that the connection between, let's say, Grasshopper and Revit was quite helpful in the end to create a more, let's say, realistic overview of the project. I'm kind of curious to how easy it is to go back and forth between the two, because I mean, in the cones, you guys kind of mentioned that there are certain geometries that get duplicated, or for example, that curves are not really Revit's best friend. But is it easy to test various solutions, or you kind of have to start off with a very close to final design before you move on to Revit?
Well, that's a very interesting point, actually. This project, especially this project, was one of those projects that could use this whole integration between the BIM systems and their computational design part from the very beginning. One thing to mention is that we have started working on their projects halfway through the seminar. So basically, the projects have been developed outside of this BIM system. So they've been developed as a normal computational design workflow. And at some point, we have started integrating all these BIM systems. And well, as you saw in the video, the very interesting approach that they have this kind of what they refer to as the space syntax. I like to call it a solver or an engine that is basically solving and generating their design. However, this engine was giving out a very, or maybe it is giving out because the project is not finished, but the output of this solver is a very basic geometrical information, and that's actually 2D curves as the output. And then there's a long way from converting these 2D curves into an actual building model where you can quantify and you can start basically measuring your project and measuring your design. And this is something that was totally automated through this process of basically using Rhino.Inside and SPKL. So they managed to take these curves as the input to the system, and as the output, they have the full model with all the schedules and everything already being there. The point is that the solver needs some input also, and that input is basically kind of an evaluation to their design. And they could actually use this Revit model for querying and then creating a loop between Revit and Grasshopper, between their solver engine and basically their Revit model. And closing this loop could basically help them to solve this whole system using the integration at the very beginning. However, we started a bit late with their project, and the solver was already working fine without using the BIM systems. So we just integrated the design into the BIM system, and the workflow is still a very interesting automated workflow. At least to me, it was very interesting to have a very basic 2D plans or 2D actually curves of a building, and having the whole model being lively updated to that. So that I think was the most interesting point to this project.
Sure, I know that also time-wise it was kind of limiting because you guys have been developing your studio project and then doing this in the meantime. But do you think of maybe adding more details? For example, looking at your envelope, I thought it would be cool to start considering joinery, like length of elements, and really taking this even further from conceptual and closer to, let's say, an actually a structure that can potentially actually be built. Because I think the envelope was kind of, still on the point of just form exploration rather than actually, like a system of elements. I don't know how easy it would be to integrate joints within Revit, I guess.
So I think that also depends on each of the projects, because depending on how much farther along they could develop a project in studio, so that was the level that they could actually bring stuff to this course. And you will see that in different projects there are distinct level of detail in a way. But yes, it's definitely much more interesting when there's more detail, because the challenge is a bit higher. No, Alexander, I see you wanna speak.
Yeah, I'd like to respond to the question, as this was like purely to our group project. So regarding the facade that you asked about, regarding doing schedules and putting it more into reality, we didn't do it yet, but during the class with Ardashir and Stefaner, we had other examples for where we actually did similar skin or similar facade systems with all the documentation for each and every single beam. So introducing documentation, introducing the joinery, I think we might be able to do it for the next week's studio submission.
Great.
Hey,
So
thank you.
keep on the lookout. Keep an eye on the studio submission, which is also happening next week. Yes, everything is a work in progress. No, sorry to interrupt. Go ahead.
Sorry. I think it's really important to have in mind that what part of Revit we are trying to integrate Rhino in, actually, because since it's still in development, this system, the different parts, it's kind of different to, for example, in beams, you can really integrate it. In walls, there are some limitations and so on. So for joinery, yes, you can maybe integrate them, but they're going to be limited in the information that they have.
Absolutely. I have a question for Alexander, precisely, if you don't mind, because I know that you have had some experience before with other software like ArchiCAD, for example, to bring stuff from Rhino to ArchiCAD, and I would like to know your take, your honest take on how this is different, and if in any way that has also contributed to the workflow that you previously knew from Rhino to ArchiCAD.
I mean, it has not been a very professional experience when it comes to ArchiCAD, Grasshopper Live Connection, unfortunately, but I did it for my thesis, and it was much less developed than the Rhino.Inside, unfortunately. It still had some parts which were working a little bit better, but nevertheless, it was not the Rhino.Inside ArchiCAD it was doing with the live connection. And this live connection was very unstable, and it had tendencies to crash a lot, which is not the case with Revit, which is a really nice thing, because like it almost never crashed on us while we're working. The only issue is that, of course, like as I'm not an Revit user, I don't know all the tricks and workarounds in Revit, and I sometimes struggle and pull my hair when there are some parts which I cannot do well, and I know that I should be able to do them. So yeah, like for now, also the ArchiCAD Grasshopper Live Connection is not being developed right now. I know that we should probably ask Luis Fraguada about this, because I know that he's been working on this thing, or at least he's been dealing with the information. Because when I was searching for ArchiCAD Grasshopper Live Connection, I saw him talking in the McNeil forums about the development of the project.
Thanks for your candid opinion, Alexander. I don't know,
And
are
I think
So maybe we have to
should
move to the next
move to the next group, yes,
Yeah,
and
because
start or continue the discussion from their starting point.
Yeah, that's a very good point. So let me open the presentation here. Okay.
Hi, this is Group 2. Natalie Voinova, Joao Silva, and Sergei Krychkov. We're presenting the design of the power and water plant for the lunar settlement on the slope of the Shackleton crater. Our concept is informed by the site conditions, the sun angle, and the extreme conditions, no atmosphere, harsh radiation, and extreme temperature differences between day and night. The extremities of the lunar environment can be avoided by digging underground. The temperature becomes constant and the radiation is blocked by the regolith. We suggest blowing a series of nuclear bombs over and under the lunar surface to create craters and caves. Thanks to the low gravity, the caves created by the explosion will not collapse under the weight of the regolith and stay as the amazing spaces with the walls of the regolith baked into the volcanic glass. We expect the explosions to create the spaces that will resemble the earthly cathedrals or cisterns, and they will be the only spaces intended for humans. On the surface, we plan to install only the solar harvesting equipment, the centric sun concentrators. Our project consists of the following parts: the sunflower forest, the freestanding sun collectors, each charging one battery, which then is picked by the user, kind of solar Uber, the shells over the craters on surface, one for the ice to melt, one for the humans to enter, and one for the robots to pick the goods from the underground storage, the prismatic sun shafts to deliver light into the storage caves, the systems of tunnels for circulation, and the caves themselves, one for the water reservoir and several for production and storage. All the surface structures deal with the sun, and their form is informed by the sun study. They reflect, concentrate, harvest, or redirect the sun. The shells are linked to different types of underground space: a shallow crater for the entry, shafts and tunnels, and the caves. And now, please, Joao.
Yeah, our workflow depended on four main software tools. Grasshopper was used to generate form and parameterization of the building, while Rhino provided the detailing and aggregation of the multiple Grasshopper scripts. To change information between us, we used Speckle, and Revit was used both as a technical evaluation tool to check scale, levels, and measurements, and as a documentation factory for sections, plans, axonometries, and renders. The usage of these programs was, of course, not a very linear system. After establishing a live link connection, we were able to effortlessly move from design and redesign stages to documenting the project. We decided early on to separate workflow between geometry and its evaluation. Geometry was produced with multiple Grasshopper scripts and streamed through Speckle to the team members. Evaluation, both environmental and structural, had its own streams. We then aggregated all of these things together into one complete model that we used to push the project into the Revit environment. We organized the project by function, aggregating the multiple units of caves, of tunnels, of shells, and each of these was sent out as a group to Revit so that we could easily re-update the geometry as a group with a live link. In order to use Rhino.Inside Revit, we decided to take advantage of the category picker through direct shape. The topography was sent through add topography component in order to manage the heavy mesh of the terrain, and each of the different kinds of elements from our project, the caves, the forests, the trees, the light shafts, were sent in different categories. This way we could easily manipulate their visualization through the viewing template. Our project is not very similar to a regular architectural project, as we don't have any walls or slabs or windows or doors. And we have very complex and irregular shapes that come from the construction method of explosions. So our approach was to send all these various elements, group them together and send them as different categories so we could easily update them and customize their appearance through the viewing template. There was also no need for scheduling because of the nature of the project, but we focused on establishing a script that could very easily allow us to update all the project. The difficulties were mainly focused on the meshes. Revit was treating the meshes as solid mass, and the workaround was to transform them into open meshes. But still, the visualization was not very flexible. Connecting and disconnecting components also required the manual cleaning process to delete the old geometry, which was sometimes very time-consuming. But definitely, we had many advantages. Time-saving workflow for the design updates to become presentable technical layouts, and also using the plugins from Grasshopper directly inside the Revit environment really gave us a fast evaluation of the design.
As Joel said before, during the project, we imported most of the models from Grasshopper and Revit and some extra parts from Rhino. Then we arranged levels, axes, and dimensions. The way we have created plan sections and master plan. Also, we create an explosion diagram through the special Revit function. All drawings and images were added to the sheets. Using graphic templates, we adjust their appearance, detailing images, hatches, shadows, and etc. Then all the sheets were grouped into a single file. The main advantage of Revit, in our opinion, is the simplification and automation of many workflows, which speed up the work of an architect greatly. As for complications, we were faced with the fact that the complex and heavy imported model greatly slowed down the program. Here we must confess that this is the first time for everyone in our team using Revit. All three of us are from ArchiCAD and Rhino based. After that, we placed the cameras in the model and created visualization using the built-in Revit render and showed different views of the project. Top overall views, zoom-ins, surface views, and interiors. Thank you, that's it.
Thank you very much.
Thank you.
Okay. So congratulations for developing this very amazing project. And well, the very basic fact that they managed to basically have a BIM model of such a complicated underground basically design was, I think for me at least, it was really amazing, because I almost had my own doubts about, is it even possible to create such a project in the BIM system and still have some takeaways from it, and like not to see it as more of a problem than a solution. However, as you could see, this amount of complexity in like explosion created caves and all this well, basically over the surface complicated designed structures were basically integrated into a BIM system. And through this integration, probably the very first piece of data that is added to the system is an identity for each of the objects. And I found it rather interesting. One other thing to remember is that Revit is actually more of a construction software than a design software. So what you see here, basically, as soon as you basically create this BIM model, you're enabling a lot of potentials that probably will just show up during a construction phase more than a design phase. Creating schedules, creating all these material quantities, and all this kind of data that you probably don't really care much in your conceptual design phase, but they start to become more and more important as the project moves on. So again, congratulations for developing such a complicated design and integrating it rather automatically into the system.
Right, guys, I really enjoyed that. Congratulations from my side as well. I think it was a very well, provoking and thought-provoking exploration. And I also think you're making a really valid argument for the importance of flexibility between, you know, like different programs, and in this case, let's say the Rhino to Revit, because you're dealing with something that initially lays on unpredictability. You're basically saying we will create these huge caves and craters. We have no idea what will actually come out of that once we make the big kaboom, right? But we have everything next prepared in terms of steps in order to create like a quantifiable proposal, which is it's really interesting. I mean, you can almost start imagining how this can realistically be done through, you know, like just 3D scanning your cavities and then just readapting your design from that point on. So I found it really really like thought-provoking, and it kind of started this inner processes. I think it's very cool, and you should definitely continue developing that further, because it has a lot of food there. And I think that's all from my side. Thank you guys, and congratulations.
Yes, same here. I mean, you somehow unintendedly stepped in a very complex project, which was, of course, in the beginning, from the very beginning, the idea that first you would somehow be proposed to create freely, you know, and find like this very nuanced form finding techniques, like the one that you just saw in this project, which is actually probably the one of the most innovative constructions technique that I've seen. You know, form finding through explosions, and then this also may be relevant to all of the projects, but because after so much freedom, then you in a second stage you would need to figure out how to document this. You know, if in a way to operate in this way, it's kind of different to how you actually would operate, because when you start the project by thinking how the tool would limit you, then the project itself is somehow limited by the project, you know, by the tool. So if you start by thinking that you would have to deliver a project in Revit, then probably you will end up having these more standardized projects to begin with. And I think in your case, it's perfectly visible that even when proposing such a challenge of an innovative fabrication technique, and part of your project ends up being so, in a way, spontaneous or kind of bespoke, it's nice to see that even in this level you can actually you know, bring this to a proper documentation tool like Revit. So thanks for tackling the challenge in a way. Thanks for you know, stepping up to the challenge of actually bringing this super nuanced project into some very strict and rigid platform like Revit. I think there's a lot to learn there for sure.
And I also want to add that I think this project brings a very important aspect of adding construction information in the BIM models. So in this case of, on the one hand, we have the form finding by explosion that you tested in Grasshopper, but in the reality of the construction of this project, there are these two steps. When first you need to insert the details and the references of how and where and when, probably even to place the bombs or to create the explosions. And then you have a second step of where you could start, as Nicole was saying, from a 3D scanning of the result and then develop the rest of the project. So I think it's very interesting to see how these new methods of construction could actually become elements inside the BIM model.
Well, I think it's really important to keep in mind that it's not only Rhino adding modeling options to Revit. Revit is also adding some information to the Rhino. So it's kind of a loop that goes back and forth, and it really helps considering this project actually.
Yeah, I think that's true. As mentioned by all of you, actually, the automated process for creating all the documents, even for the list of it, is basically something that matters the most here, because it's easy to imagine that you create an explosion and the cave that is formed is basically not what you really expected. And there's always this parameter of surprise, I would say, or maybe even a parameter of not being so sure about the formal creation of basically the whole design. And that is where you actually need this very automated workflow to basically be able to update the project as fast as possible based on the outcome of, well, in your case, an explosion, or it could be basically any other factor that can dramatically change the course of the design at some point during the construction process. So I think that's it for group 2. So maybe we have a quick break before moving on to the other groups, if there is no other comments for this.
Sure, as you want, Aditya, you run the show.
Okay, very good. So let's say maybe a 5 to 10 minutes break. It's fine.
Let's come back here in 7 minutes. Actually, 8.
Yeah, that's a good point. Okay.
Thank you.
Hello.
Hello.
Can we all come back from the break?
Hi, I'm here.
Hi, David. I thought you were going to be a bit late.
Even though I tried to be late, I can manage.
I can imagine that says we have too much time. You try to be late and you cannot.
Nice.
Okay.
So, Ardeshir, should we go to group 3?
Yep. So we can start with group 3. Let me share my screen first.
Great.
Okay, and we start by moving to group 3.
Hello, we're Group 3 and we welcome you to our meditation temple, Moonscape. We will start off the presentation with a brief introduction of our project, followed by our understanding of Rhino.Inside Revit, how we molded our workflow, and some drawings explaining our form and design.
The project is actually part of our studio project, and the site is actually located in the south pole of Moon. And the proposed project is a meditation temple for the lunar community.
Rhino.Inside blurred the boundaries between these two areas of specialization within computational design and BIM. So with Rhino.Inside, the computational side starts to come to the BIM side and BIM coming to the computational side. So this diagram shows Rhino is on one side, Revit at the other side, and Grasshopper is kind of the middleman that speaks between the two, which allowed easier access and also helped in extending the process of design into documentation process. The second is the process where we have the design model, and at the same time we have a Revit output, which allowed us to explore options and utilize the powerful parametric Revit families.
When we start to develop our project, we try to implement as much as possible this workflow. So we have in a way translated in understanding the inputs coming from the context, the colony, and the research, and bringing for Rhino and Grasshopper as a starting from our design, as a starting point from our design. When the design starts to get directions, then we start to actually create other elements as ramps, internal shell, external shell, internal dome, floors and walls and components. And all this workflow end up in the second Grasshopper file, which was doing the communication with the Rhino.Inside. And this stage we called interoperability, which means that we could also, as we were using Rhino.Inside Revit, coming back to the design again in a loop workflow. And that also gives us a chance to have any time of the project cards and design database, interoperability model database, and instantiation.
We split the form into 7 different layers to organize not only our workflow and also categorize it into our files. All the layers of forms, although molded in different modeling tools, were integrated into different Revit categories. Our workflow included modeling geometry for the external temple in Grasshopper and the internal temple in Rhinoceros. All the geometry was combined into a single Grasshopper script and assigned Revit categories. We prepared a base Revit file with levels, origin, units defined to match the parameters of a Grasshopper script and linked all the files into one.
So we then go into the plans and the detailed drawings. So the drawings are actually directly extracted from Revit and taken into post-production. So assigning categories for each of these elements helped us in extracting the drawings with the level of detail that we actually wanted, and also helped in taking the post-production work much more easier. So by combining Rhino.Inside Revit and the Grasshopper workflow and the parametric model that we developed was able to be integrated into Revit, and we are able to extract the building data and schedules from the model. So here we have the plan, and first ground floor, which hosts the service rooms and the entrance vestibule. And next slide. So in the second floor, here we have the meditation cells and the worship areas. And for the most outermost plan has the outer temple and the main worship space. So this is an explored axial view of the temple with the different parts of it. We have the access ramps which leads to the main temple, and then the temple is made up of these different shells that come together and protects the building. And then it has the internal ramp and everything that is included within the temple. And here we see a sectional view of the temple with the different spatial distribution. The elevation of the same.
And here we talked about how it was the experience using the Rhino.Inside. We believe that the Rhino.Inside has narrowed down the gap that exists between Rhino and Revit, and the potential of this workflow is actually very interesting. The capacity to associate design decisions at the real-time documentation is extremely vital. Some positive points was, for example, the capacity to associate the design decisions with the real-time documentation, as mentioned, to bridge the gap between these two tools, the generative tools and BIM tools, with less exporting and importing actions. And we could also merge the design components created in Rhino with BIM categories, creating a possibility to schedule them easily. Some difficulties that we experienced was the fact that Rhino.Inside Revit workflows work better when between both systems, when both systems work in parallel. And what I'm trying to say with that is that if we should have bring Rhino.Inside Revit earlier in the process, if you were familiar with the workflow, then it would be even more efficient. In some situations, some of the Revit components, we felt that we were using Grasshopper, we felt that we were really sensitive. That means that even they were extracting the geometry correctly, they were still showing some errors in the components. We believe that that might be regarding the way the geometry is built, but is very sensitive. And when the complexity of the geometry increases, it's not always easy to understand when the elements are being updated. And that was a situation that has led us to some mistakes. That's the end. Thank you so much.
Thank you.
Okay. So, congratulations, guys, for this amazing project of yours that you just presented. I see this project as a successful integration of these different platforms, and they managed to basically create a link between the good features of every of the platforms that they needed. So Revit is, as they presented, Revit comes in as a secondary platform after the design process was complete. However, it's kind of interesting for me to know how this system could basically be integrated into the system from an earlier stage of the design, because well, it's true, it's making iterating the design much easier. So having this system and creating this system, having all the schedules and quantity of the materials and everything, and then having all these amazing presentation documents that you managed to create through Revit. Well, all in all, this makes iterating the design much easier, right? However, what could be the feedback loop in this system? So how could this information that is being added to the model in the Revit can basically come back into the design decisions and basically inform the design? That's something that basically was rather interesting in this project for me. And well, this is still an open question, I guess. Okay, any comments?
Yeah, I can comment on it. What we felt is that we introduced Revit in a phase that we were kind of secure with the design, but really quick we understood that we didn't have to. We could actually have jumped into Revit much earlier because the workflow and the way we were working in Grasshopper was easily reacting in Revit. So any change that we were doing, it would be translated in the workflow. So in that sense, we were a bit kind of disappointed that we didn't introduce so in an earlier phase. But we were not familiar. We were not so familiar with the workflow. So in that sense, we were a bit more going traditional in a way. But we could definitely have inserted earlier, and we believe that it could have we could have worked in parallel. So we didn't have to have so many people working in design. Maybe other people could have been working in Revit and others in the design, and merging a more efficient to the team. I think that's what give us what can give us back is actually that the workflow becomes much more efficient.
Okay, thank you.
Pedro, I think that's right on the spot comment, because one of the main challenges, as we've seen from the beginning of the term, is always to be able to produce changes and in detail from early stages of design. And that is not only true for the projects in high complexity like the ones that you have developed, but also for kind of like one of the main challenges in general in the Bim paradigm in the industry nowadays, because as you know, being able to introduce these changes in early stages also means a lot of saving costs from the production side. And when you also include fabrication techniques such as robotic fabrication or other more advanced digital fabrication that like in a way are incorporated in all of your projects, that definitely has a positive impact in the project's balance. So I think that the comment is quite on the spot.
Thank you.
Yeah, I also believe that having the ease of documentation, so with your final drawings, if we could have seen, let's say, I mean, as you said, you have integrated Revit quite later on once the design was done. But then, I mean, for future projects, it's kind of great to be able to communicate in such a, let's say, professional way, all the different iterations through the development of the project, which can be very beneficial, and also communicating to a client certain decisions that you take within the design. So yeah, I think what Ardeshir was saying is really also what I was thinking for, I guess, for all of your projects so far, the how do you take advantage of Revit's features in this case to create proper documentation through the entire design process. But it was a really great work, guys. So congrats.
Yeah.
Okay, very nice. Thank you for the comments. And if there's no more comments, we can move on to the next group.
Yeah, I think we can move on to the next group. I just want to say again to the students and everyone who is joining us today, feel free to comment on your colleagues' work, but don't feel pressured to respond to questions. This is more of an open discussion. We are actually all here to ask and respond to questions together as a community.
Thank you. So let's share the next presentation.
Good morning, everyone. So, as you already know, we are developing a project on the moon. Our team, which is Group 4, Felipe, Quechua, and Basel. So we are looking at sports centers in the moon. So the presentation will be divided in 5 parts. So the first, we will talk about the introduction of how the project was developed, then a bit of like the workflow, followed by the project development and the opportunities and limitations. And at the end, we will show some visualizations that we were able to do in Revit. So for the introduction, in essence, the design objectives, our project aims to provide a sports center on the moon, where we try to test different gravity forces and somehow recreate that in form. So initially we started looking at the distribution of the program, and we compare what was the distribution of the program on the Earth and how was that reflected on the moon and how could be adapted on the moon. So we start looking at artificial gravity in a sense that we can minimize like health and well-being impacts on moon inhabitants. And we did a bit of research, and we start looking at like the different ways like how NASA is implementing this idea in their projects. So initially we start looking at the radius, like an optimal radius for the centrifuge. We run a quick optimization process in Wallace where we're looking at the different equations, and then we end up with a preferred length of a radius for the main centrifuge. Overall, the project is divided into 4 parts. So we have a main torus, which is horizontally. Then we split the project into the underground levels. We have also the access levels, and then on the top part, we have the sport grounds. In terms of the workflow, overall, we start with a form exploration process that it was done in Maya and Rhino. Then we took that form and we did a little bit of refinement and parameterization in Rhino and Grasshopper, followed by the documentation and detailing what that it was done in Revit and Rhino.Inside. And we use Speckle and Rhino.Inside to transfer the data between Rhino and Revit. For the modeling strategy, so we had an initial model and scripting that it was done in Rhino and Grasshopper, and then we split that into different segments. So the model was divided into different segments, and some of them include different floors and also the basement levels, the facade envelope, structural model, and the internal modules. And then we link that back into Revit as a central model to produce all the documentation and all the drawings. So for the parametric approach, so we generate a form that it was able to adapt to the terrain, and that somehow we could also change the radius of the torus. The sections could respond to the terrain, and also the number of grids that we are using as the main structure, so we could control those as well. We also did a quick test of where was the best approach for the terrain. So we test like that idea of self-orientating and how the project could be adjustable to the moon's terrain. And then, as I already mentioned, so we start looking at the different levels or segments of the project. So we divided and split the project into different segments. So for the project development, in terms of the internal module, so we start with a module that we developed in Rhino, and then we took that as a generic model in Revit, and we start adding walls and detailing the whole process. So we took it as a family in using Rhino.Inside. This is one of the modules. At the end, we have 3 different modules, and the idea was that each module has a different use, and that can help us to complement the overall form. So on the second model, we have like a service central area, and then 2 spaces on each side, which help us to have different uses. And the third one that we have was the completely opposite. So the service was on the bottom part, and then we have like a more open area on the top part that allow us to have a different type of program. So for the first part, the level 3 to 4 is where we located the main sport complex. That's on the top level. And then we basically did a sort of like a basic program where we have like the sports field with all the complementary uses. So we have toilets and the standings area and so on. This is one of the floor plans that we got in Revit, and again, it's showing the different uses that we have on that level. Then for the second part, so we have between level 1 and 2, which is the main access level, and we end up like having sort of like different platforms at a different height, so people can jump, and that's the way that they circulate in the project. So some of the uses that we have in here is yoga area. We have also a tennis training area and a running track. And as you can see, the torus is already embedded into the form, which we'll explain later. Again, this is a floor plan just showing the distribution of the program and how they relate to the main torus. For the third part, so we have all the basements and the underground level. So this is kind of like the main access level to the project, and this is the level where we have access to the torus, and we have like series of enclosed spaces supported by landscape areas. Yeah, so this is the floor plan, and again, like different uses where we have landscape, we have running areas, we have yoga and recreation areas. So some of the sections that we got in Revit, and overall the idea was that once the model was updated into Rhino and Grasshopper, the workflow allow us to update very quickly all the documentation process for the project. And now I will pass it up to Basil that is going to explain the torus.
So yeah, so this is actually the torus. We actually separated the torus in a separate file because of how heavy it was and how difficult it was to integrate with the rest of the model. And because actually the torus was difficult to understand and difficult to dissection for in its actual state, because people are actually oriented, let's just say towards the outside and towards because of the centrifugal effect. Then next, yeah. So you can see the I'm sorry. Yeah, you can see that it's made up of the exterior body for the torus and internal pods. The pods are actually separate from each other, and then they're connected later on, right? We consider that it's constructed on Earth, and we connect the pods once they get to the moon, and we connect them to each other, and then it starts rotating within the body of the torus. This is just a simple elevation and section of the torus, and you can see that it's actually circular. It has a circular cross section. This is an interesting element that we started utilizing in design, and that made it also easier to solve the structure of the torus, how it could hold up together using beams and frames. So this is a diagrammatic example of the plan and section of elongated when it's actually turned into like almost a linear design when you unwrap the torus, right? And this is how it looks like from the inside. Okay. So the one on the top is like the fan, and the one below is the section. And this is an exploded axonometric of the torus, showing the different elements and the different construction elements of the torus. So it's actually held. It's actually held by the body, like the body is exterior, and then it's held by frames. And these frames are connected to magnets, and these magnets use they propel the pods, and the pods have a superconductor, right? That's cool, a high temperature superconductor that is cool, so that it could get propelled by the magnets, right? And the body of the pod itself is held by frames and beams that are connected, and then there are other internal elements like spaces for hiking and paths that are inside the doors. Okay, so we'll discuss a bit the opportunities and limitations that we faced in working in this in the different workflows that we had to input our data in Revit. We had like two options, the Speckle and Rhino.Inside, and both of them were actually pretty good options. We mostly used Speckle because it allowed faster integration between our workflows, so we don't have to send the model to each and every one of us, and then he would then use Rhino.Inside. We could just automatically send it to Speckle to the Revit model. Obviously, we faced an issue when we tried to do that with the torus model because it had so many elements. It broke the Speckle plugin, so we ended up not using Speckle for that specific use, but in overall we depended mostly on Speckle. Okay. So some of the issues that we had is when we input the geometry, sometimes it would sometimes show as a filled object, as a solid object, when it obviously wasn't, because it was actually made up of panels. But then this is how we would face it. This is how it would show up. And when the faculty, some of them tried it, it didn't show up in their in the files, and that's something we don't know what exactly caused the issue. Okay, so yeah, yeah, so we ended up using adaptive components for the facade panels, and that solved the issue. So they ended up being different facade panels, and they were not solid elements, and we were able to model the facade flawlessly. Before inputting it in Revit, we were actually thinking about all of these panels and all of these different parts. And so it was interesting that we thought maybe we could reduce the number of panels as much as possible to maintain the shape of the volume, but and then the project, but at the same time not use too many elements and too many different, not have a unique element for each and every panel. And so we ended up with a total of about 200 families, right, for 1,900 panels, which is much lower than it used to be at the beginning, obviously using machine learning and clustering. So the construction process was actually thought of as a process where we start by digging like the underground area of the project, and then we would start inputting the frames, right, and then connecting these frames temporarily, right, and then excavating the areas between the frames, and then using using a substructure, right, which is obviously our panels or the structure holding panels, right, and it will be distributed above the structure, right, so that we then later remove the temporary connections, and we end up having the product as you can see in the GIF. Yeah. Okay, and these are like renders from Revit. So this is how the project looks right now in Revit. I think it looks okay. Obviously, one of the issues that we faced as well was the terrain, but I think this is how it should work because it won't be solved with Revit. I think that was what we eventually learned. Thank you for
Thank you.
this. Yes.
Okay. Thank you for this presentation. However, yes, for a 5-minute presentation, and so we need to basically speed up a bit the process of commenting. First of all, congratulations for developing this project, and well, I think you made a very good attempt on using this feature of Revit, which is basically assembling different files and assembling different structures together. The most interesting part is that you managed to create this very amazing structure for your project in terms of how you divide the project into pieces and into parts. And this is one of the things that BIM systems prove rather useful in, because since all the objects have their own identity and their properties, it's rather easy to assemble different parts of the project together as one aggregated identity, and basically start creating all the presentations and documents from there. So you managed to basically utilize this feature rather well, and I think this was a rather interesting approach to have. And as you mentioned about using different platforms like Speckle and Rhino.Inside, well, since you're achieving what you want, which is basically giving these properties and this identity and converting the models from a 3D based model or basically a geometric model into some elements, into some architectural elements, well, I guess that's the goal, and whatever platform you use to achieve that is just fine.
I think it's really interesting to actually compare some of the projects together to see that which part they're focusing on. For example, in this project, as soon as they start to use the adaptive components, there are a lot more details to work with. And I think that's because the developments is different in different kinds of Revit and Rhino.Inside actually. So it's important what the project is focusing on. That's an interesting point of view, I think.
I think on that line, I was probably not super convinced with the negotiation between program and shape, which is more on the design side or more on the concept side rather than on the platform. But I was missing how it almost seemed like you've created your final design and then you just put your programs or your like sporting facilities according to the global geometry rather than trying to balance out between the two. So having sort of a feedback also from the program to your global geometry. And I also thought it was very clear that once you started designing the torus, because it was a simpler geometry or a geometry that you could easily like integrate into Revit, you started creating a lot more complexity and detailing it out. And probably it would also make sense to detail it even further into creating certain quantities or values, because I think that you do have all the different elements. So it would be also interesting to understand in terms of, you know, like panels, how many there should be, or like, I don't know, I always think that maybe costs can also be somehow calculated based on the information you get. Yeah, I found a lack of balance between your elements, which probably comes from the focus of what you wanted to develop further. And I think there's a little bit of disconnection between some of the elements of the project, which you can definitely look into, because if you manage to polish that out, you have a very strong proposal. And in any case, thank you guys.
True. I second what Nicole just said, and also I think there was a lot of the presentation of yours that had a lot more to do with the project development than the Rhino Revit interaction. So it would have been nice to focus more on the struggles that you guys had and to see the level of detail that you were aiming to achieve, at least for the project, which probably could be done even in the next couple of weeks. In any case, I think it's interesting. One of the interesting aspects that I see is how also the documentation can inform, like retro-inform the design process by, in a way, attempting to optimize the modules, right? Because you guys are in a point to become aware that maybe documenting or actually eventually producing or fabricating so many modules, so many panels of a different of a different aspect ratio is going to be very difficult. So it's also one of the positive aspects of introducing this in early stages of design is to be able to anticipate this and also retrofit this information to the design intentions so that you can actually reduce the amount of components that you have, so that it will be in the end also easier, both not only to document but also to fabricate in the end. So even though, I mean, this idea is kind of in a way embryonic still in the project, but still I think it's a quite interesting idea to follow, that the current paradigm of construction it's not only linear, but it's also kind of focused in a way that you have managed to develop the project to so much level of complexity that it can actually retrofit the fabrication technique, and you can anticipate these kind of fabrication issues and change the project accordingly before it comes to production eventually. So I think that's one of the interesting aspects that you guys have touched. And in any case, thanks for the nice presentation.
Okay, thank you very much. So maybe we move a bit faster to the next group if there is no additional comments. Okay, so let me share my screen for the next group. Okay, so we move on to group 5.
Hi, we are group 5. It's me, Marissa, and my colleague Hisham and Human. And we are doing the Moon residence for the studio project and also for integrative modeling course. And the next slide, we can see that our main strategies for the Rhino 1 residence is modularity, adaptability, self-assembly, and individuality. They are the key drivers to this residence project. To cater to the varying needs of all the individuals and family, a catalog of components gives the users flexibility and autonomy over their living space. Breaking down the project into parts allows us to address the construction issues on the moon. It also allows the project to be more adaptable and go according to the needs of the colony. And on the next slide, we want to create a self-sustainable lunar community that doesn't just solve the technical challenges, but also thrives on it. We believe that the radical inclusion, modification, communal effort, radical self-reliance, participation, and an extreme approach to leave no trace ethic towards our community. So looking at the project, we divided it into 3 scales, micro, meso, and macro, to tackle the entire project. It comprises of modular parts that come together at different scales. And we made this decision at the start of the project to look at how we can combine modularity and individual parts to form the entire aggregated community. So looking at now the project methodology, having set up the project as a kit of parts, the idea is to have a chain of parametric process from the start of the component creation, the analysis, and then finally to the seed selection. Our intention is to be able to have a seamless design to drawing production flow, allowing changes to be made at any point without disrupting the process. So we started to look at the project in terms of a static process at the very beginning, to fulfill the needs of the users of the residents on an individual basis, such as looking at the programs and spaces they will need. And then we jumped onto a dynamic process, which is then using the parts that we've developed in static to create an aggregation of individual living units that is optimized on the command level. And so we came up with 7 modules within the entire project. We have 3 living units and 1 communal hub, 2 connection modules, and 1 structure column, and that comprises the entire project with different possibilities of different navigations. And I'll pass now to Herman to talk about our workflow.
Thank you. And as Marisha mentioned, we created an automated process that is being taken care of on a single Grasshopper script. That we start with a human UI configurator that allows us to create an app interface where the user can actually just interact with this interface and not have to actually interact with the rest of the Grasshopper or the compute component. And then we use WASP in order to create the navigation rules, and then Caramba and Ladybug to run the analysis. And then we use Rhino.Inside and Speckle to then do the different kind of Bim and URL exports as well. And as you can see on this next image, this is a series of screenshots of the configuration we have created where the entire process is being taken care of. And start from the left, going all the way to the right. And as you can see here on this next video, that we show the entire process on how the configurator take care of the workflow. And as you can see here, we select starting and connection points with the different neighbors. And these connection points and these different vectors allow us to then specify different volumes and constraints in order how they want to run the aggregation. And then we run to the second part when actually we run the aggregation, and also we can indicate how many parts we want for each component and how big the community we want to be. At this process, the process is still completely automated. So allow us at any point to revisit the position of the aggregation, the future connections, and the amount of connections we want. And then we got into the analysis process. And as you can see in this particular snippet, where we can actually run a radiation analysis and be able to tell us how many hours of sun and exposure to radiation a community is using it. And then based on these results, allow us to then choose a different seed. And then after we run the analysis and we're happy with the final configuration, we can then run a big export. And as you can see, we're using Rhino.Inside to then create a live connection with Revit. Level to use sites and also each of the parts. And as well, each of the parts has a huge amount of data that allow us to then specify and measure how many parts we have for each scenario. Then we go into the next scenario. We're going to talk about a little bit more about our approach about using Rhino.Inside. Our initial attempt was actually to use the nested component approach that has proven in Revit is the most efficient way to deal with these kind of discrete elements. So we were thinking actually to take each individual component, like smile, like dine in, relax, sanitize, and sleep, create individual Revit families for it, and then be able to nest these families into the module components. Unfortunately, we tried this approach, but Rhino.Inside didn't allow us to then have this kind of nodes and coding access to it. That's why we have to revisit our approach. And what we did is we break each of the modules into his skin, into his wireframe, into his nodes and his interior parts. And each one of these ones, it will come a different family, as Hisham will explain later. This gives us a really interesting benefit that our entire aggregation has more than 3,500 different parts, but all the parts are families. And this allows us to then have a Revit file size that was not bigger than 50 megs in total and was completely fast and efficient. But on the other side, we have to do a lot of heavy lifting at the beginning, creating all different component families. But at least this process was automated. So I'm now passing to my colleague Hisham, who's going to talk about the Revit documentation.
So we started to create our families for the residential units and the circulation parts. So here we see our 3 main units, 3 prototypes for 2 persons, 4 persons, and for 2 persons in vertical direction. And mainly we have 3 categories for the families. So we have the interior elements category, we have the structure system category, and we have the protective skin category. And for each category in the next slide, we are creating different families. So mainly we have 6 families. So the first family is a structural members, second family is a structural nodes, and interior elements, inflatable mesh, wheat fabric, and the last family number 6 is the glass windows. And from these families, we are creating our parts, and then using Rhino.Inside, we are sending these families to create the whole unit, and then we are creating automated drawings from that. So in that sheet, we can see 2 orthogonal views and sections, and here we can see different plans for the same unit. And we repeated the same process of creating different families and automated drawings for the different units. So here we have the same set for the 4 people units, the same 6 families, and the same automated 2D and 3D drawings and different floor plans. And again, the same process done for the 2-person unit, vertical unit, 6 families, and then automated drawings for like different views and different plans, and adding automated levels, automated dimensions. And I'll pass it now to Herman to talk more about the different data that we can extract from these units.
So as Hisham mentioned, this family approach that it was quite interesting in order to create all different families and allow us to get into a much more granular detailed level of information, because it allows us to then, through using Rhino.Inside, automate the creation of the parameters and also the data we want to embed into each of the components. And as you can see here, each one of the families we created has a huge amount of data embedded that through the creation of automated Revit schedules on the Revit side, it allows us to then document all of that. As you can see here on the top right scenario, we have a structural quantity schedule. That is, every time we run an aggregation through the configurator, and up to this point, the whole process is still automated. It allows us to understand how many cubic meters of 3D printed material we need in total in order to print all elements. And as you can see here, for instance, this particular aggregation, that is the C15, it has 6,132 structural tubes. And in order to, this allows us to then keep running the configurator, and we will actually decrease or increase these quantities. And as you can see on the one underneath, we have the same properties for the skin and the envelopes that specify how many quantities, the quantities we have for each of the components. And then this is also part of the automated Revit creation process, and all of this is being created through using Rhino.Inside, the macro site plan, micro site plan, all the different levels. So this shows the interiors and all the connections. And also using filtering and view templating to automate and colorate all of these scenarios. And we got into the different elevations and also doing automated and creating using tags. Then we got into the section as well, where we also using view templating and also filtering for the coloring. And then we got into this exploded axonometric scenario, where you can actually see all the different components and the total aggregation of the community. And I hope you enjoy it. Thank you.
Thanks.
Thank you.
Okay. Wow, thank you very much. And congratulations for, first of all, developing your own software using just Revit, Rhino, and Grasshopper. And also for developing such a complicated, and I want to also mention, huge project that you have already managed to create. Well, I think this model that you have managed to create and this approach you have, well, interestingly, this amazingly represents your design logic as well. And this idea of like, I think you kind of finished the whole idea of modulating the design or whatever. So there's not much left to say there. And also you had a very interesting approach to using Revit in terms of like, well, it's a totally, let's say, different approach to using all the capabilities and features of Revit. For example, you break your design to the smallest pieces of it, and then you manage to create Revit objects out of these smallest pieces, and then you have this amazing process of assembling all these pieces into your design. And you also managed to make the whole thing kind of automated. So I think you achieved this dream of yours that we discussed in the very beginning of the seminar, of changing one parameter in an interface and almost having even your CNC toolpaths ready on the other end of the process. So congratulations, and well, I'm passing the comments to Jules. Nicole, I see your...
I have nothing to say. This is really great, guys. I mean, it was quite mind-blowing also in terms of quantity of work. I think you really made a super strong argument for the workflow as well. and it's yeah, it's hard to say anything beyond congratulations. I hope you keep on using your skills for good, and yeah, congrats, guys.
Yes, I agree with Nicole. Please use your skills for good, not evil. Actually, it is an amazing project, and it's amazing, definitely an exemplary workflow that you have established. I'll ask you a question though. I mean, it's fair to say that here in this group there was some previous BIM knowledge, right? Herman is quite knowledgeable in BIM, and he knows also the the ups and downs of and the challenges that this takes. And I think it would be also interesting to hear his take on from one who has some previous Revit knowledge and has also faced some of the the difficulties in interoperability before. So Herman, do you want to speak a little bit about that? I mean, what has, in a way, what has the course contributed to your previous knowledge? That's what I'm asking.
Yeah, thanks. I think first of all, I tried Rhino.Inside before on the early stages, and I got this early disappointment a little bit because I tried maybe too early. But now on this new take, it kind of opened a new door of opportunities in my mind, and how we can really now take the standardized production of architecture that we used to think on Revit as this kind of production machine that puts us in a box. And now in a certain way, how can we unleash the beast, and connect it further and bring more complex process into it? But also on the other side, I think I brought good knowledge and BIM into the process, but then it's amazing to see how the tools, they're so well explained and so well documented these days and so easy to use. And then Marisa and Hisham, I mean, by the end, we were saying, the three of us, and we can be BIM managers now, in a sense. And the three of us contribute an equal portion of that. And it's amazing to see how technology that is so disrupting, it can quickly be adapted. I mean, for me, the fascinating part was you don't need now massive courses and really complicated process to implement it now in practice. This is something we can immediately implement it. And I think it's our responsibility as architects to kind of, open new opportunities from Revit and connect it now to more complex processes. And I think it is fascinating. So it's been a really good experience.
Thanks a lot for your thoughts.
Thank you, Herman. I have to say congratulations. This was a almost perfect project. I mean, you guys did really well. I have nothing to say.
Yeah, as David mentioned, they managed to do most of this on their own actually. So we want to congratulate you again, and well, very amazing job. So maybe let me just open the presentation from the next group.
I wonder if any of the students or any of our student guests have anything to add or say about what they saw. Any ones that are not part of this team.
I just want to congratulate the guys because it's been a very inspirational work throughout the whole semester. So yeah.
So if I may make a quick parenthesis, BIM is one of the aspects that we see in MaCAD, and of course, each of the students has a different expertise on different subjects, no? And so sometimes it happens that some are more previously knowledgeable in BIM, some others are going to be more knowledgeable on AI in the next module if they're joining us as well. But I think the main takeaway or the goal is that everyone kind of learns something according to their own level, according to their own previous knowledge, and especially according to what they intend to use in their future endeavors. You know? So I think one of the things that I'm really happy to see in this course particularly is that somehow it has gotten contagious, and to see people that have been involved in BIM helping out other people as well raise their level because they have been sharing their previous knowledge with them, answering questions in the forum or directly talking to them. I think that's also one of the one of the main spirits that we try to encourage in MaCAD, so that we can eventually all learn from each other, not just from teacher students. So thanks for those who are raising everyone's level.
Okay, so thank you very much, David. I was wondering if we should take a break before starting with the next group, because the next one is going to be a 16-minute presentation. So maybe it's better to have a break before the presentation. So
let's take a very quick 5 minutes break.
Okay. Do you want to have another 8-minute break? Why not?
Sorry?
8 minutes is fine again?
I'm not sure if we will manage to see and have enough time for all the projects, so I think it's
Okay,
better to take 5 minutes.
Okay.
Great.
Thank you.
Okay, thank you, Anne. Thank you, Arish.
Hi, I'm back.
Hello.
Hi again.
I guess this is the first time you guys see me in my IAC scenario, no?
Yeah, that's true actually. So
Yeah. They
okay.
managed to bring me out from my cave today.
Yeah, really, this is something that doesn't happen every day.
No. I try to stay at home.
Okay, good.
No, especially for safety reasons, more than for practical reasons. But once in a while, have to come and
I think we
check what's
still
happening.
miss the paint on the background you used to have. The
Ah,
masterpiece.
yeah, that's the masterpiece of that's Leila's masterpiece. I've been getting some really tempting offers for that piece already. So if you guys don't sharpen up,
We should sell it on. We should sell it as an NFT then, huh?
oh yeah, absolutely. Absolutely. Maybe she'll. No, that's the way we can afford her college tuition in a few years from now.
I think you may need to add some space because she'll probably produce a lot more very soon.
Yeah. Well, we don't want her arts to be devaluated, so we're gonna keep her from painting. Whenever you're ready, guys, we can continue.
Yeah, so let's continue maybe because we're a bit running out of time. So we're going to continue with group 6 and let's see how this goes.
Hello, welcome to the presentation for integrative modeling. This is group 6, Paulina, Sachin, and myself, Amar. Our project is called Noah's Botanical Garden and Wildlife Reserve. And the main intention of this project is to create a natural.
Oops. Okay, maybe. Okay, let me download this file.
Yeah.
Okay, I have to share my screen then.
Hello, welcome to the presentation for integrative modeling. This is group 6, Paulina, Sachin, and myself, Amar. Our project is called Noah's Botanical Garden and Wildlife Reserve. And the main intention of this project is to create a natural habitat for a certain number of species, both for the plant and animal kingdom. And the aim is to have an array of spaces with varying degrees of volume, gravitational force, temperature, and natural light. This will give the plants and animals the opportunity to gradually adapt to the moon's environment and also allow them to choose which environments they want to live in. Over time, we want them to be in harmony with their new environment and create a unique ecosystem. So looking at the various differences between the Earth and Moon conditions, we are focusing on gravity and temperature. So creating different varying degrees of temperature and gravity, which in this diagram, we're showing how we are creating hot environments on the left-hand side and the cold environment on the right-hand side, and a mid temperature in the center, and the gravity slowly decreases from the bottom half as you go further up towards the upper part of the structure. And this gives an overview of our project, starting from the exterior to the interior zones. So we have the outer regolith layer, and then the internal zones, the circulation, outer shell, the chambers, the infrastructure, and the mechanics. And this is a section, static section of that overview, showing all the different layers of the project, which we will explain in more detail in the next few slides. So this gives a better overview of those different components within our project, starting with the infrastructure, and then the chambers, the envelope for the chambers, the inner regolith layer, the circulation inside the regolith, and then the outer regolith layer. This shows in more detail the regolith layer. We have the outer skin structure, which is 3 meters thick to protect from radiation and meteorites. The core or sphere that creates the adaptive condition for animals, the circulation part within the regolith for visitors to walk around and experience the wildlife reserve, the volume and services for animals to create different habitats within the structure, and then a grid shell structure to support the regolith layer. And the animation on the right shows how we created the outer regolith using Calibra mesh crawl on the grid shell structure. And this gives an overview of how the site, how the design of the project sits on the site, and the overall dimensions, which is 330 meters by 285 meters. So it is quite a large project in relation to all the other projects. So in essence, we have two sides to our project. One is the interior core, which is more the adaptive chambers, the infrastructure, and the visitor areas. And on the outer, we have the ecological animal reserve and garden, and also the circulation or the interaction space for the visitors.
Sachin? You can go, I think.
Yeah. So the workflow for our project included seamlessly working between Revit and Rhino. In Rhino, we were working with the parametric stuff, which is designing the parametric elements, which are the spherical elements of the infrastructure, which will go in detail in the coming slides. Then we designed the outer regolith inside Grasshopper, which is again also done using Calibra, and designing the the overall outer structure inside Rhino. We used Revit for our documentation purposes, and also designing the infrastructure, the furniture, and the various elements of our design. We use Speckle to transfer data amongst all three of us in our final project, and the context is integrated using the Speckle works. Since the Rhino model was quite heavy, we used work sessions inside Rhino to divide our model into three parts, which is the context, the core, and the regolith part. This made our model quite less heavy, and we were able to work quite nicely after that. We used Grasshopper to design various parametric elements inside our building, which are the spheres, the outer metaball structure, and the rotation of the spheres. We used Rhino to create the parametric design elements. All the graphical drawings have been exported from Rhino. The animations, the GIFs, and the renders are taken from there.
And in regards to the Revit models, as an output, we use Revit to produce architectural plans and sections, area plans, area schedules, axonometric views, as well as furniture plans. So we have multiple Revit files that were linked into a single federated Revit file that consists of the Revit core infrastructure, the metable volume, the chambers, and all the other components that were part of the Rhino geometry. In regards to the models, so we have two absolutely independent models, which are the Revit core infrastructure and the Rhino regulated circulation. The other Revit models are Rhino Revit interlinked and interdependent models. So we basically used an initial Revit file in which we set certain coordinates around which the Grasshopper geometry was allocated. The same is valid for the regolith envelope as well as the chambers. We spent some time in Revit and Rhino.Inside to import all the Rhino geometry in the right categories as per the project function. For example, floors or this outer shell was imported as structural beam system. We also imported some of the glazing or the windows. And at certain moments when the Rhino Revit interoperability was not possible, meaning that we have too complex geometry to import to Revit, we basically modified the native Rhino geometry into something simpler. For example, in this case, our outer regolith layer was divided into single isocurves. And then it was imported to Revit, where still it could be documented and used for sections, plans, and whatever. Here is one of the suggested workflows that we've used in our project. Starting from our native Revit infrastructure, with Rhino.Inside, we exported the rooms and selected them by names. And afterwards, we selected the center of the room. Based on the center, our Grasshopper script was creating the so-called chambers or spheres around the infrastructure. So in that sense, it is very interlinked. If something happens in the Revit file, let's say we change the wall's location and the room moves, so will the chambers in the Grasshopper definition, because they're just picking up the coordinates from the rooms. We also spent some time on fixing the rooms, so they're precise not only in terms of perimeter, but also in terms of height. The same is happening in regards to the metable envelope of the chambers, which are also working in the script with the centers of the rooms locations. We used also a similar workflow when we wanted to create a pattern in our walls, because the whole infrastructure will be glass and it will be 3D printed glass. So basically what we used was to allocate all the initial Revit walls to a Revit native face, use Rhino.Inside to export the walls into Rhino, and then slice these walls and create a pattern in the walls that is using a Grasshopper 3D printing tool, and then send this geometry back to Revit in a new phase, which is called Rhino Informed Phase. So at the moment, this workflow has been tested and it is working, but since our project is still in development for the final studio presentation, which will be in 3 weeks, so in the model we can see the phasing, but not all walls have been currently as a the 3D pattern is not there fully yet. And in this process between Revit and Rhino, there are definitely some lessons learned that probably is worth sharing. When it is about very complex and large-scale geometry, as in our project, as in our case, linked files work much better, both in Rhino and Revit. There is a problem when it comes to shared coordinates between Rhino and Revit. At least we were not able to do that. In that sense, probably also storing the geometry in separate linked files is a good idea, because if something happens to the Revit file, let's say project node is being moved or something like that, this is not going to be picked up in the Grasshopper and Rhino file, so you're going to have a problem. So if you slice the geometry in different Revit files, that would be much easier to control. So our solution of getting geometry, let's say like in our case of the walls, sending Revit walls to Rhino, getting them informed and sending them back to Revit, because we have overlapping geometries. Phasing is our suggestion, but also perhaps options is another one that could be used. Revit options. When initially we used just the opening the Rhino geometry and Grasshopper geometry in Revit, we saw that it is not good for documentation just because of the way it comes as a shaded geometry. So it doesn't come as proper lines. For this reason, Rhino.Inside is useful to create Rhino geometry to native Revit geometry for documentation purposes. If you have too heavy Rhino geometry and you want to convert it to Revit native geometry, it could help to reduce the mesh or convert it to sub-D and then convert it back to a mesh or slide the geometry. And if none of these methods work when you try to convert very big Rhino geometry into Revit geometry, you could just think about something else. Like in our case, with our outer regolith layer, we converted these to isocurves and then imported the isocurves into Revit, and this still works perfectly for documentation purposes. And at the moment when you open our infrastructure core Revit file, you will see basically walls, floors, doors, rooms, generic models and furniture, as well as the foundations. And based on these walls, we created the rooms. So and those rooms got exported to Rhino and Grasshopper and are controlling partly the scripts. Also, we exported quite a few area plans, as well as normal architectural plans and sections, which you can see separately as a part of our submission.
So yeah, so apart from designing our building, the site and the context has been set up on Speckle, and so this is the current stream which we are using to work amongst ourselves and also with the other 9 groups in our studio. Next slide. Yeah. So this is a site which is on the moon. We are a total of 10 groups who are working to build this colony. And so Speckle, we use Speckle to update all the locations on our site. And this work has been, Speckle has been very effective in transferring all the data. And this was quite helpful, I will say. So that's it. Thank you.
Thank you.
Thank you.
Okay. Thank you very much for developing this project and also your very interesting explorations in terms of setting up the workflows. Well, I personally find the workflows you have made rather interesting because you You guys have managed to take the idea of using Revit as more of a documentation and presentation part of the project into basically utilizing and using all other different parts of this software as well. One of the very cool features of Revit, or one of the good potentials that this software have, is basically the modification possibilities that it gives you. So maybe modifying a 3D model or geometrical model is rather easy. However, this gets much easier in Revit. So Revit has spent a lot of time on basically developing these features so that you're able to modify your model very easily. And I think in the workflow that you presented to basically extract the walls from the Revit, creating these 3D printed versions in Rhino, and then putting them back into the Revit model, that's a very interesting workflow and very interesting approach, because then it's super easy to modify your model all the time, right? So you basically modify inside Revit with all the features and all the tools it has provided for you, and then with a click of a button, you have your rather complicated 3D printed version of your model already updated. Also, this approach to, for example, extract rooms to create the metaballs from Revit. So instead of spending a lot of time creating all this information that you need inside Rhino and then creating the model and exporting to Revit just for documentation, you have managed to successfully extract the information that Rhino has created for you, which, for example, is finding these rooms and creating the boundaries and like using finding the center of the room. And this basically, I want to say, well, these loops that you have created in your workflow, that you extract data from Revit, you create something in Rhino, and then you port it back to Revit. It's, I think, a very interesting approach. Also, congratulations on developing your design, which I find rather interesting, like managing this level of complexity with these crazy meshes and everything is I think, some mentionable achievement. Well, as you said previously, also it's a bit weird to see all these geometries and all these shapes in Revit at the end, but you have managed to successfully basically create an integrated workflow between software. So congratulations, and I pass it to Juris for any comments.
Yeah, guys, congratulations. That was actually really interesting to follow. And I totally agree with Ardashir. The way that you've managed to look back and forth between the softwares and take kind of the best of both was really interesting. I personally very much enjoyed the ingenuity of solutions that you were coming up with as you were facing problems within the workflow. And I think it does show that, first of all, you became very familiar with the limitations of, let's say, of Revit, and you managed to somehow create like this almost hacking solutions in order to extract what you needed in the end, which was very, yeah, it was very interesting to follow. And I also know that we are a little bit late, so I will not take any more time, but thank you.
Yes, so we are a little bit late, and that was a long presentation.
Can I just add something here?
Sure.
Sure. As we were talking earlier, I think this was a perfect example of what Revit adds to Rhino instead of the other way around, because Rhino is obviously adding modeling tools for Revit. That's for sure. But what they have done here, then created the loop, it really shows how Revit can help Rhino.
Okay, amazing. If we can have one more comment while I'm downloading the next presentation.
Thanks. Rather than a comment, I will also try to, I want to put Paulina on the spot a bit here, because she also has like a BIM background, in asking her what would be her kind of her best takeaway from this new knowledge that you've gained in this course, and whether you would actually implement this in your current workflow.
Yeah, thanks for all the comments. I was wondering if you're gonna think we're crazy or like actually enjoy the experiments. We saw this as an experiment, or I think the whole group and myself. I think there is definitely actual real life examples. Even the 3D printing wall example in itself is a very good example, because in Revit you can only create flat layers. Like you cannot create like curly sort of layers. You can create 2D for 2D, but not like geometrically 3D. So I think that's a very good example of how Revit and Rhino.Inside can be useful to each other. And yeah, I mean, you know, the more exposed you get to these sort of scenarios, I guess the more hacks we'll find. And yeah, that's it. I don't know what else.
Thank you,
Thanks,
Paulina.
Okay. Thank you very much.
I think we could move to the next
yeah, I'm just
presentation.
playing the next presentation now. So let's move on to group 7.
Hello.
And now I'm going to share my screen.
Hello. Today we're gonna present about our project. We are from group 7. We are the project called LEAF. We are working on the lunar enchantment and agricultural farming, which is located on the moon. So here is our project, the space farm, located in between the 3 neighbors. Our project have a radius of 40 meters, and we are working on the inclined terrain. So we decided to go underground. And here is our plan arrangement for the programs. Then we develop into the architectural planning in the geometry in Revit. So our concept idea is to have like 3 different layers, including the outer shell, the inner shell, and the interior underground space. So in this case, we can protect the people and the living farm from the space radiation. Then we're gonna start with the interior program workflow, which Alex gonna explain about this.
Yes, we actually started to by looking at the Grasshopper, and then soon we realized that we actually overcomplicated things, and we could have just relied on the existing tools within Revit to modeling all these simple repetitive geometries and make use of the existing families and elements in Revit to enrich our interiors. And we just follow the very simple way that is taught in the tutorial about how to use Revit to complete our interior. And next slide.
And there is the inner shell, like inside about outer shell, and the module is based on the inflatable structure. So I used the kangaroo simulation to simulating the inflatable structure, and also using the Weaverbird definition to generate the frame. And there are 7 like a major module has the different function. So there is the domain and the vegetable, insect, and etc. So there are like a specific design. So we designed for the different windows. And next, please. And also the inner shell looks simple, but actually it's based on the construction method. So we're using the 3D printing and the construction method. So this is illustrate how we're gonna process the building. And we use the Revit, Rhino.Inside to referencing the point from the Revit. So we can building this structure like individually, but it will be like a fit perfectly later because we're using the same reference point. Also, we're using the like a Grasshopper definition to generating everything automatically.
Then we move to the outer shell. In this case, we are looking at the tessellation and the paneling stuff. So I use the Kangaroo and Lunchbox machine learning to clusterize a group of similar panels and according to the area, its length and orientations and deviations. So we can have like a different size of cluster according to the size of the paneling and also the location. In this case, not only just group it, we also average the size of each cluster into unified shape in order to put it back to the surface. In this case, we can have a set of the family construct. Also, the workflow that I use is to use like a Grasshopper, and then we integrated with the adaptive components inside the Revit. So by constructing the family first, then we apply the requirements input. In this case, we're using the points. So the point will be identify the shape of the geometry, and we have a set out of the 4 different types of the panel according to the number of points, including the hexagonal panel, rectangular, pentagon, and octagonal. And below is the sheet showing the number of the panel in our project. Moreover, we are developing into the create the opening on each panel. So in this case, we can have more variation to like functioning as a light providing. So just to conclude, this is our workflow. So starting with Revit and Rhino, then we try to combine it. The more like a diagrammatic and computational design will generate with the Rhino and Grasshopper, while more technical stuff will brought to the Revit part. And then we conclude all the file into one file, which is the base drawing setting that we have, like set all the views and the template. So the outer shell using the Revit, Grasshopper, Rhino, as well as the inner shell. Meanwhile, the interior will focus on the Revit part. So moreover, we are also like integrate with the other tools, include for create the diagrams like Illustrator, like we use the base as from the Revit, and then we develop in the Illustrator for beautiful diagrams. And here is our drawings, starting from outer shell, inner shell, and interior space. We also have done the exploded drawings and also the diagram that specify what is the element that we want to show in one color. So can also like in the here we can have like a different scale of the drawings to zoom in to illustrate what's happening inside our building. And also we are like develop our section according to our geometry by using the hexagonal clipping plane that we have drawn on top of the plan. So we got this output of this shape for each individual plan. So basically what we have learned like how to exchange the file and workflow of the design, like between the Revit and Rhino and also Grasshopper, and more like we learn how to create the family and type of the object and specify what is going to be and how to edit it like individually according to the type. And also what we have faced, I think like I will let Dongyap explain about the problem that we have faced.
Actually, when we merge it all together, like after individually working, actually there was a kind of like issue because of the reference even if there is the same reference to be working on, but still the coordinate is different, or sometimes the scale is not very like a match each other. So so when we like merging the different file format or the different the application, the function and feature is a little bit different. So there is a kind of a conflict. So there was the issue. And also like we working like individually different time zones. So when we have the meeting, it's like when it's working, I mean, meeting same time, it's kind of, yeah, it's not that easy as we thought before.
Maybe
and our solution,
yeah, can explain about
and our solution. We watch the lecture repeatedly, slow down, and follow the things step by step. And also the supporting session is very helpful and very practical to resolve our problem. And we use Google and all the online resource to help to solve our problem. And we also got a couple classmates who are BIM manager, and they are giving us some advice to how to solve our problem. So yeah, thanks to all of you and them as well. Yeah.
And that's it. Our presentation.
Thank you.
And
Okay. Thank you very much for your very good work. So you, I found some still very interesting ideas in the work problems and everything. So this idea of for example, creating these adaptive components, which are basically some kind of a smart families, a smart components of Revit that can basically adapt to the situation and can adapt to their powerful feature, and then taking this feature and combining it with Grasshopper, because normally, like, okay, you have this component that can adapt to all these parameters, but how to give the parameters as inputs, especially when you have a lot of the components. And then using Grasshopper to basically having this parametric or basically this approach for automating the process of adding the input and basically using your adaptive component as a very powerful component of Revit is kind of an interesting integration of the two platforms. So this is also one of the cases, one of the projects that, as you just mentioned, you could use Revit to basically convert your very basic data in terms of like schematic plans and things into an actual like building model. And probably it could basically help you a lot if you were to use Revit from the very beginning. So this is an experience probably for the next time. So, do you have congratulations at the end? And if you have any other comments from the jury before moving on?
Yeah, just super quick. I think it was extremely clear, guys. The workflow was very easy to follow, and it seemed that you have a very complete proposal in the end, taking advantage of all the different aspects of the different programs. So it was, yeah, it was incredibly rich and also very easy to understand, like the steps that you took. I was almost a little bit surprised when in the end you said that you were having difficulties because of time zones and not being able to, you know, like meet, because I didn't get that impression from the project. And yeah, congrats. I think I've seen it before during your mid review, and you've made kind of like leaps and bumps since then. So cool, congrats.
Yeah, I agree. Thanks, guys. Especially because it seems that you have really made good use of the tool and focused particularly on developing this part for this occasion, which I think shows that you know, it has taken some effort from your side, but you've managed to somehow rise to the challenge of bringing this complex project into Revit, in spite of all of the changes that I know you guys have had throughout the studio. And also, I think you also benefited from somehow, even if not entirely, introduce this workflow in a rather early stage of your project, and that helped you learn a lot of the struggles that you would have to face and foresee those, and then also in a way, yeah, in a way also that there's always things that you have to choose to get around or avoid, and I think that's super interesting. So thanks, guys.
I think this is a very common struggle and a very common pain point, I would say, for in architecture, where we are very resistant of introducing BIM tools very early in the design process, but actually this is something that could be very, we could all benefit from it quite a lot. So I'm wondering if the students, again, maybe not this specific group, but any of the students have actually a thought of how they could introduce BIM very early in the design process, in the creative process and research process, moving on. I think you're muted now.
Oh yeah, thank you so much. So my colleagues are working right now, so I'm the only one who joined here. So on my behalf of the team, we are not have never experienced in Revit before in this program, so this is our first time, and then we try to learn everything by watching a lot of videos. I mean, the course here that we have learned is this. I think is a good start for us to have a really strong basic knowledge to implement in the future step of our career. And yeah, nothing to say, but just thank you. We will keep working hard for the studio for next week.
For sure. Thank you so much.
Thank you, guys.
For the work.
Thank you, guys.
I think we could move to the next video if there is no further comments.
Our project is Selino Bio.
So moving to the next group, which will be group 8, I believe, yes. And there we go.
Our project is Selino Biohabitat. It's a residential on the moon. It's an experiment of a practical concept of growth with time, capable of producing viable community dwellings as biospecies at any given moment of growth. Our drivers to make a sustainable colony were related to economy and nature and social. They have their impacts on the structure, its tectonics, and the construction techniques and the growth. Our process of interoperability takes a Rhino platform as a platform for making complex geometry into a platform of management and collaboration, such as Revit. Our parameters of design started from experiments on growth patterns, and later on we developed parameters that went through our growth.
So in terms of the workflow of the project, we started out creating all the design in Grasshopper and Rhino, and then pushed it into the Revit using Rhino.Inside, Revit, and Speckle. So we started out by generating a growth algorithm using Python in Grasshopper, and this is how we define the configuration. And then we started creating the elements, and we started with floors, and we generated them in Grasshopper. and push them into Revit using native Revit elements and based on the floor outlines. And then we generated the skin, and we generated them as a BREPs and then had to transform them as a mesh to allow seamless transfer into Revit. And we used Speckle to create generic models of wall types in Revit. In terms of internal walls, we created them in Rhino and then used Grasshopper to parametrically distribute them into each unit. And we push them into Revit using generic models of wall type. In terms of structure, we generated it in Grasshopper using geometry gym plugin. We made analysis in Karamba and connected the domes using Grasshopper elements. So having this model in Grasshopper, we then pushed it into Revit using Speckle, and where we created native Revit elements based on the Grasshopper geometry. So here is the sprint from the Grasshopper geometry, and it's done using 9 elements, and those 9 elements are then pushed into Revit, creating a native Revit element of family 5. And we used create schema object in Speckle, and we pushed the stream from Grasshopper into Revit using Speckle.
Regarding the cons and pros in our project, we found out that regarding the cons, we observed that if the workflow is not planned, there is a high risk of increasing the project development time. And Revit does not support imported custom freeform shapes efficiently and does not model complex geometry. And this complex geometry cannot be transferred into native families, and generic models cannot be easily manipulated. As well, we found out that the external references reduce file size, but they require a lot of manual work in Revit. And regarding the pros, we conclude that the combination between the Rhino and Revit created a winning interoperability workflow for complex geometry, because on one hand, Revit is great for documentation, collaboration, and management. And on the other hand, Rhino generates easily custom freeform shapes and allows using external applications such as Geometry Gym. And the Speckle was used for the final transfer of geometry, as it was the fastest method. We only used Rhino.Inside in the initial phase because it was really useful to transfer surfaces. Here we can see part of the process of how we integrated both of the software into our workflow.
And here are some of the lessons partially listed. The capabilities and limitations of Revit, Rhino.Inside, and the Speckle should be recognized at the early stages of design. It is recommended to break down the imported model from Rhino Grasshopper into parts, and interoperability success is limited to native Revit contents.
Okay. Thank you very much for this presentation. Actually, you had a very nice example of basically using Revit, combining Revit's native elements with all this basically simply created data that you have generated through Rhino and Grasshopper. So, for example, well, as you just mentioned, having a line structure and then having the line model of the structure and converting it to actual beams. Well, as you can guess, the benefits are beyond just presenting and documentation, because you're adding information, right? You have this line model of your structure, which is basically just some lines representing the elements. But as soon as you integrate the Revit and you use Revit native elements, to create that, you're adding all these other information like the profile and the size of each of the elements, and like, for example, the materials and quantities and everything. And well, as mentioned multiple times by now, it's gonna show its real potentials when the project rolls further into next design phases and also into the construction phase, because that's where this kind of information and these schedules and everything is gonna really is actually going to matter the most. So if there's any other comments from the juries, since we are running a bit out of time, so I just kept it quick.
Yeah, just congrats, guys. I think probably you can go a bit further into like different layers of complexity when it goes to the Revit side of things. I think you concentrated basically on the envelope or on the shell, which was great, and it was well documented. But yeah, it seems that there are certain levels of the project that never got to Revit, especially because you're working on a sort of residential thing, if I'm not wrong. So most likely you'd have also like walls and doors and whatnot, and other elements. But the design is super nice and it was very well presented. So nevertheless, congratulations.
Absolutely, I again concur with Nicole and Alshir, especially because you've managed to make out of a simple project, what started as a simple project in the beginning, something that has risen to the level of complexity that it's required from the courses, also from the studio. And not only but implementing that nice modular approach, which in the beginning would somehow, from an external point of view, look in a way simplistic, but when you start to see the project more into detail, like zooming out into the details of the project, it really shows that all of the concepts that you set out for in the beginning of the studio are represented also as elements in these plans, in the planification of the project, and then in the drafting through Rhino.Inside. So I really hope that has also been a learning experience for you, because in a way this kind of rising up to the challenge has been, the bar has been set kind of individually, and I think you guys have actually raised the bar at each step so that the projects only gain in complexity. And I have to say also it was actually a really good idea to tandem the studio projects and this seminar in specifically shows in your project, because from the studio side, I can only see that it has gained a lot in terms of becoming more realistic. So so great job, guys. I'm smiling behind the mask.
Thank you very much. So group 9, the video, I'm having a problem with the video I downloaded because there are some characters at the end that I cannot play. So I'm going to skip to group 10 and then we're going to jump back to group 9. My apologies for
Hi everyone, we are the group 10.
Getting out of the order. So maybe let's move on to the next group. Congratulations again to group 8 for developing the project.
Yeah, really good job, Chris. Thank you.
You did a rather clean, amazing job. So let me show this again. Okay.
Hi everyone, we are the group 10. My name is Barbara, and in our group is Jaime and Shelly. We are responsible for designing entertainment virtual reality center. VR is the main drive for our design. We wanted to create this big open spaces that, besides feasible in the moon, would be also good enough to host VR activities. Our project overview, we have 4 main structures: a mixed-use vault, an underground station, a VR pods vault, and an arena vault. We are showing all the types of geometry that we have developed for this project, from the terrain to the underground station and circulation, the foundation, the baseboard and inflated formwork, and also the 3D printed interlocking panels. Here is a very quick GIF that shows a little bit of our construction sequence, and this is our computational workflow. The general workflow is we developed everything in Rhino Vault, also with of Grasshopper, and we took it to Revit to detail the model, to extract technical information and other data. And in the next slide is to explain a little bit of our computational workflow regarding the design process. First we started defining the program, then we created this compress only vaults, and then we went into three different fronts. One creating the station and the tunnels, creating the foundation for the station and the tunnels. The other one creating the inflatable formwork and the inner divisions with inflatable. And the third one defining tiles in an assembly mechanism that could be 3D printed and creating the tessellation vaults. Everything together, we transferred it to Revit to add walls, doors, equipment, and furniture, and also generate and detail the views. This slide shows a little bit more about the interoperability steps into details. Each type of geometry, we experimented some alternatives to take things from Rhino to Revit, and we used mainly Rhino.Inside Revit and Speckle, and these are the details for each type of geometry. Also, when we got to Revit, we created for each one of these geometries a different Revit file, so we could work in a main file with linked other RVT.
Considering this computational workflow, we imported our Rhino geometry and our Grasshopper geometry using Rhino.Inside Revit and Speckle. But during this process, we experimented some problems. For example, at the beginning, as we worked in Rhino in meters, then the tolerance when sending it to Revit with direct shape with Rhino.Inside Revit got multiplied, and we got this kind of error. These were the geometry directly didn't got into Revit because the tolerance, also this one, where some tiles were getting there, but others didn't. And when we did it with the Speckle, we faced the problems that some elements were getting in as Rhino B-reps and others were getting in as messes. Also well, the tiles was the main part that we had more issues to get them into Revit. But also we experimented some problems with the station getting from Rhino, and the 3D box is not working with this upper part, but it is working in 2D the other way around with the bottom part. The positive things that we have seen doing this, going from Rhino to Revit, is the availability of this interoperability technology, because it is easier to collaborate between disciplines and other agents, allows one to take advantage of its software strength. For example, Revit is much better for documentation, for collaboration, for information modeling, and Rhino is much better for complex modeling. Also, we found good working with a server with Speckle because we can collaborative work remotely. And the negative things is that it is a quite difficult process to change native geometries between softwares. Also, it's a long and difficult process when trying to import large files or unusual geometries into Revit. And software technologies is still in development, which sometimes leads into extra work in some parts of the data science. With this, we learned that we have to work in the same units in all the software since the beginning to avoid these tolerance problems, that it is better to exchange native Revit elements, either with Revit inside Rhino inside Revit or Speckle. And it's better to work with parametric basic modeling from Grasshopper, which later can translate into generative native Revit elements.
And these are showing our final results. This is level 2, which shows the circular staircase, the inner partitions, and the connection tunnel. And this is showing level 1 final results with the tunnel connections and the central hub. And this is showing a breakdown of the rooms. This is showing level 0. This is a section of the final results showing the diaphragm walls, doors, inflatables, and vaults. This is showing the tiles that came through, but we weren't able to bring them all in successfully. So you can see some of them there are the meshes with the extra lines. And this is the 3D section. Here we're showing the central hub again with 3 connecting tunnels and the stairs, which were created in Revit.
Okay, thank you very much for developing this project and developing this model. So since we've been closely in contact about all the problems you ran into, so I think you've been the only group up until now that been using a model that was generated using Rhino vaults. And well, using Rhino vault, since the structure comes first and that's what you actually care about the most, you had a lot of technical problems dealing with the geometry that is produced in terms of like you ran into technical problems with tolerances and with like some open models and everything. However, you finally managed to basically solve all these technical problems and having your structural design first approach to be basically finally integrated into Revit. So we hope that now that you have all your problems fixed more or less, you can actually start developing the complications and everything much more for at least your studio projects. However, I think I have to congratulate you to finally coming up with all these technical problems at first, which for solving some of them, we had to go as deep as like finding out how the whole system is working and what is the underlying problem in terms of like how Rhino stores the geometry and how Revit translates it into some geometries and everything. So very good work in terms of technical development of the situation. However, I think there is a bit more to do for your studio final. Thank you very much.
Yeah, I think I'm also missing a couple of tables and information being extracted. But as Agdashir was saying, it seems that you're now kind of on the verge of having almost all the problems solved in order to really take advantage of Revit. But nevertheless, and that's kind of a general comment, I find it very fascinating how everybody has kind of gotten to the point when you have a very complicated geometry and you try to put it into Revit, which is not really made for that. And then you face all of these various, you know, like I would say like interesting problems. And I think this builds up to a great like body of research and something that hopefully will soon be integrated also into Revit a little bit more fluidly. So I think you're all doing a great work in development through your, let's say, experimentation. So that's like a general congratulations to all of the groups till now and probably the next 2 or 3 that are upcoming. I think your guys are really, well, kind of building up to a difference into the workflow that probably eventually will become kind of a normal of weird geometries in actual building information modeling. So congrats.
Yeah, that's a dream. And unfortunately, there's only one group left. I know we're already at over time. So if there's any other comments from the David.
I'm sorry to say I'm going to have to leave also because of time, guys. But I mean, first of all, regarding this project, I also know firsthand the struggle that they have been going through with, you know, trying to negotiate between custom pieces that they create with their tessellation and also a more standardized shape. And it's been kind of a roller coaster, no? Of on the one hand, the design intent, which should be kept standard, and on the other hand, how to make this really documentable. But I think, in a way, this is a project that I feel it could kind of skip the documentation part and just feed straight out fabrication information in the end. And of course, this is an exercise that we have to go to learn all of the challenges. And I think these guys have, with all of the experience that they have already in BIM, they have done a great job of tackling it. And but as a general comment for all of the group, I think I have to say that it's super impressive to see so many approaches for so many different challenges, either in the case of complex forming or complex shapes or standardization, or being able to bring a lot of elements into the Revit model, and the different strategies that you guys have come up with. I think it's really something. It's been super nice to see you guys work on this in the Slack channel, like actively hearing your problems and seeing how you guys tackle them. And I really thank you guys for exposing these issues now, which I think really are the issues that we're facing nowadays with the introduction of pieces that are more and more bespoke and more performative and less standard. You know? So thanks a lot, guys, for putting this together. And sadly, I'm gonna have to leave, but I'll try to catch up with the last group afterwards. Ciao,
Thank you
guys.
very much, David.
See
Thank you for all the amazing
See you
comments,
the next
and
occasion.
thank you for joining us for this session. Hope
It's been my pleasure, as always.
Thank you very much.
See you soon, guys.
Oh,
Thank you very much. Bye.
thank you very much, and we say goodbye to you for now. So, without losing any more time, we're going to jump to the last group. My apologies for going over time, and hopefully we can wrap this up in a few minutes more. So this is group 9, and this is the
We are
presentation.
team 9, Kim and Sumer. We are going to present our project of Lunar Fab Lab and Convention Center. So this is our project methodology for 10 weeks, and then right now we are at the end of the project presentation. So our collaboration computational workflow started by an analysis of site and materials and construction methods, etc. And then we use the Rhino and Grasshopper for form finding. And then for detail, we use the Revit. And then in the end, we are going to other visualization tools. So for the collaboration, we used mainly Speckle and Google Drive in order to send data to Autodesk. And then we separate the task in 2 parts, exterior, interior, in our team. And then we shared our data by 2 small stream and big mainstream. And then we have future scenario that with our Revit file, we can work with future engineers and mechanicians via BIM 360. And also we can share our project on the web by using computer coding.
In terms of the specific integrative modeling workflow within this class, we started with Rhino and Grasshopper for the actual form finding and seeking the different designs for our concepts, which then was taken using Rhino.Inside Revit, and then Speckle for internal collaboration for the design of the facade and the internal walls, and then also the project assets that were informing the design of our project. And then within Revit is where we designed all of the adaptive families for the panels and then used Revit to output drawings, 3D views, axonometrics, and also exploded axes.
So our dome is composed by 3 panels for outside, solar panels and regolith block panels and windows. And also inside there are fabric which is welded each other in order to support inner air pressure, and which is going to be also anchored in the exterior. And this is the multiple layers of our one panel. So and then which is effective for radiation micrometer rate.
In terms of the panel designs for the adaptive components, as mentioned, we used the capabilities inside of Revit to design all of our exterior solar panels, the regolith panels, the window panels, and also the interior walls and floor panels. All of these panels shared a similar typology. The only thing that was different was the thickness, which was driven due to the fact that the assemblies were different for all of these different purposes. The biggest advantage was that the usage of adaptive components created a parametric system, which allowed us to use Revit's capabilities to generate panel lists, which we see a big advantage with. And then also the panel details were controlled parametrically inside Revit, and then these could always be deployed against the massing that would either be changed or brought into Revit. The one big disadvantage we had was in our initial trial, we started to use curtain wall panels, which we found out later on after a conversation with the instructor that we didn't need to. We could have just used generalized adaptive components inside of Revit, and that would have given us a bit more ease of control for the parametric panels, and this is what we will do moving forward. For the internal walls and floors, it was the same usage of the panels, but what we tried doing here was the goal was to be able to model these walls and floors inside Revit after bringing the exterior form into Revit using Rhino.Inside. But after trying a few different aspects and the complexity of the geometries of these interior elements, we found that we were unsuccessful in order to try this. So for the sake of time and also for the completion of the project, we rationalized these forms inside Rhino and Grasshopper, applied the panelization within the Rhino.Inside Revit environment, and then brought them into Revit in order to generate the drawings. To reflect back upon the process that we have had here in this class, we'll start with the disadvantages. The number one being the compatibility, where we found that while the integration has begun, there are still limitations on the functions of Revit for complex geometries that are produced within Rhino and Grasshopper. In terms of collaboration, we use Speckle, but there was limitations on that because it is a work in progress tool, and that, you know, not having a subscription to Autodesk BIM 360, we had to at many times save files and send them back and forth to each other to use. And there was also a big learning curve with Revit, where it's a great tool, but it's somewhat restrictive in terms of geometries or complexities that you can work with. And you either have to compromise on the authorship of the design, or you can only do things to represent inside Revit and not use it for its full capabilities. Some of the biggest advantages we found that, you know, number one is the integration of Revit and also Rhino and Grasshopper has been, it definitely has changed things in terms of how we are approaching the project. The parametric control and collaboration of this power between Rhino and Grasshopper and then Revit is right down to the BIM control of Rhino geometries is a big advantage. And then the parametric control of the drawings themselves, where inside Revit there's an efficiency to creating drawings, and then also parametrically controlling them with the model changes.
So now we are going to show the our PDF file of the Revit. This is the first page, and then this is site plan, and this is the floor plan with different dimensions and sections. And this is second floor. We have only one second floor in the convention center in the upside here. And this is elevation. And then this is section with the legend here. So we decided to show here because we have a different floor, so it's easy to understand the section views. And this is construction method, construction panel, and with a list of different panels. So we try to have a different material list from different families, but our time didn't we didn't have much time to do it. But like Separ said, we can use family shared parameter to find collect different data from the family. And then this is the panel types, different panel types, and then details. And then this is also axonometric disassembly to show different layers, different structures and layers of the bones. This is axonometric 1 and 2, and that's it. Thank you.
Okay. So thank you very much for your presentation. Actually, I think I can say you're on the right track, although you might have not really reached the full benefits of using the system yet, but you're rather very close to the end. So this whole idea of basically reducing the complexity, because you have this panel designed with multiple layers and so many geometrical complexities and layers and everything, with so many parts. And then trying to solve this whole complexity, trying to basically wrap up all the complexity in one family, in one adaptive component that you've been trying to model. And then you don't even need to think about it anymore. You have solved everything in one family, and all you need to do is to basically start scattering this family all over your design, and basically just to start using it, as complex as it is. So this is a very nice approach to you basically integrating the BIM system into your design, to basically creating complex packages and wrapping them up into one family or into one package, and then start using and adding all of them together. So okay, we're a bit too much over time, so I'm going to give it short if I can have any other comments.
Yeah, super fast. I think the presentation was also very complete and it was easy to follow, guys. So congrats on that. The final documentation that you did is also pretty cool. I would invite you to revise a bit your line weight thicknesses, probably in the final drawings that you produced. But beyond that, I think you've managed to communicate the project very in a very complete manner. And I also think that the design is kind of cool, and the way that you've done the spatial distribution seems quite logical and integrated. So congrats on that. Yeah, and I do enjoy your fabrication system proposal as well. So cool.
Thank you, Nicole.
Yeah,
thank you very much.
I think you guys have focused a lot on developing these very interesting panels, and the entire project is actually based on this. So this makes it a very interesting prefabricated approach that looks really buildable, but maybe due to technical reasons and not being able to solve some problems, maybe you stopped a little bit short of actually finalizing and making use of the full potential of this by giving us a full overview of the quantities and basically using all the potential of BIM. But you are, as Nicole or Ardashir or both said, on the right track. I think, to actually achieving this finally.
Thank you very much. So I think with this, we can finally wrap up this whole pinup session. And how stupid of me. I was worried if we can fill up the 3 hours. Now we are around half an hour over the time. So, so I want to first congratulate everyone for developing these really amazing complex projects and managing to set up all these very interesting workflows. And it was as much of an exploration, and like it was an unexplored field even for us, even for me and Zipper. And this was as interesting as it was for you, hopefully for us as well, because this was some very interesting experience we had together. So I want to thank all the students first for basically your dedication and your very amazing efforts into developing these projects. I want to also have a special thanks for Uwana for setting up all the sessions and everything as a coordinator. And well, obviously, I want to basically say special thanks to Nicole for joining us for this session. Actually, it's really nice seeing you after a while. And well, as always, you had very productive comments and very amazing suggestions to make. So thank you, everyone. And I'm not going to keep it any longer. And if there's any final words you want to have.
Thank you so much, Ardashir. And I just want to say, to bring a bit of the experience of the studio where we've seen all this, we've kind of been alongside the students when they were facing all these issues that they faced with trying to bring it into Revit, but at the same time we were strongly supporting them on the concept side. And I think this course has been very successful in, on the one hand, proving how students and how us architects can break the tool that is given to us, can go all the way to the edge of what Revit is able to allow us to do, and then try to break it. But on the other side, I think Revit has also proven to us that it is still there to try and break our concepts, and especially a purely computational form-finding algorithm, by proving to us that some of the things that some of the forms that we find computationally are not buildable yet, and they need a different layer, another layer of critical thinking and another layer of optimization to basically make these forms in a way that is really ready for implementation in a real site, whether it's on the moon or on Earth.
Yeah, actually, this whole idea of working like start modeling some projects on the moon while we still have problems creating some models on the Earth. That was a very also nice aspect of this whole experience. So, you know, lunar dust and like things like that. These are things that we didn't even need to go looking out for any online resources. We knew we almost don't have anything. We have to start from scratch. So it was very interesting. Thank you for actually joining us here during this session. And well, if there's no other words, we can probably wrap this up.
Yeah, just thanks for having me, guys. It was really, really nice to see the development of the projects. And yeah, just keep up the good work. And yeah, hope to see you some other time during the MaCAD development of the year.
Yeah, I want to actually thank you again for being with us here today. It was really amazing having you here.
Thanks, guys.
Okay.
Thank you,
Separate,
everyone.
do you have any final words?
Yeah, I just want to thank everyone, all the students, and Ona and Nicole. And congratulations on the great projects you had. It was a real experience for me too. I'm really happy with everything. So thank you.
Okay. So maybe,
thank you guys for the seminar and for feedback today. Yeah.
Yeah, you're welcome. That was such an amazing experience for us as well.
Yes.
Okay, so I think I don't know. I'm hesitating to leave the meeting, so maybe Luana should just end it for everyone.
I will say that we have successfully closed this first final pinup from the second module. With this, I will stop the live